Dear students, you are welcome to the knowledge series, and today we will discuss on the soft computing. Now what exactly the computing means? The computing means that any process that we want to execute and it is going to produce a results, that particular results is more or less resemblance to the desired output, then we say that computational or that computing systems accomplish its task. Or in another word, as per the definitions which is noted here, the process of accomplishing a particular task by computing to find the mathematical solutions of the problem that is precise and accurate. That means we are very sure that the output is going to be precise and accurate based on the modeling. That is the mathematical solutions that you accomplish initially, and based on that, for the given input, you give the input, and based on the input and based on the modeling, you will be getting the output, which is the precise and the accurate conditions that has been met. Now this computing can be categorized into two forms: hard computing as well as soft computing. That word itself is known that hard computing. You can take it like examples, like a military style of or a defense style of dealing, or a defense lifestyles, as well as a conventional lifestyle. A defense lifestyle is that they are very systematic, punctual, and they meet all the conditions based on the given deadlines. Whereas in the conventional way, everything's like a public will be able to handle the things in a not in a exact replica of the military styles. So that's why the conventional methods of living is different as compared to the military styles of living. So hard computing, as the name is, that it needs that everything's under the computings, whether you talk about the mathematical modeling, you talk about the output. For the given output, it should be hard enough. There should not be any flexibility in the case of a hard computings. Soft computing, on the other hand, it's a soft in its functionings. That means the mathematical modeling, it's not a static one. It's we take the modeling and thereby we try to modify this one as on when required, so that it can dynamically change as per the need of the output for the given inputs. So this soft computing, as the name indicates, that it is a imprecise form of a computings. So let us see what exactly the soft and hard computing means. Soft computing deals with the approximate model and give a solutions to the real world problems. In our real world problem, take an example like a car is going and it has to give a brake. Driver can give a brake by immediate brake systems. That means immediately keep the legs on the brake pedal, and thereby the brake can be given at an instant. Whereas that same driver can give a brake under the slow conditions if the distance of the where it has to stop, if it is little far. So the braking systems can be soft and braking systems can be instant based on the conditions. So the real world problems is not a static problem, it's a dynamic problem. So that's why the soft computing is based on the approximate model. That is what the mathematical model is a dynamic in nature. Soft computing is an approach that gives imprecisions on the human mind. Imprecisions means that human mind is flexible to handle the things under the soft computing situations. Mind to reason and learn in an environment of uncertainty and precision. If you today we all talks about a machine learning. Machine learning approach is basically a soft computing approach because it try to learn based on the environment and based on the experiment and based on the datas. So if a new data comes based on the learned datas or based on the trained datas, the test data will able to give the results accordingly. Hard computing. Hard computing is suitable for a mathematical problem, although it might be used to solve the real world problem, but it's not 100%. It consumes a large amount of computational time and cost. That is the point is that in the hard computing, the mathematical problems when you talk, you have to create a mathematical problem based on a particular situations. As the situations changes, you have to keep on changing this one. That's why when you keep on changing this one, automatically you have to make the new setups. Hence, the new setup will be consuming time and cost. Say, for example, you are creating an amplifier of 100 watts, and for a given input, that amplifier is giving an output. But assume that you want to increase the volume so that the output can able to travel that particular signal to a far distance. Then in that case, this amplifier will not meet the requirement. Then you have to redesign an amplifier for the higher watts, say 1000 watts. So 100 to 1000 watt difference, that is you have to go for a 10 times. You have to increase the gain for a 10 times. Then in that case, new designs, so it will take its time and then the cost will increase. So that is what a hard computing means. It is a traditional approach used in computing which need accurate states in an analytical model. It was proposed by Dr. Latif Alizadeh. He is the father of the fuzzy logic. Before the soft computing was generated, this Zadeh, he is no more, but he is the pioneer of the in the modern worlds, the soft computing scenario that he has brought has changed the entire world. It deals with the binary and a crisp logic which require exact input sequentials. Whereas Latif Zadeh handled with the binary and a crisp logic, which is a part of a soft computing, whereas hard computing need exactly given inputs. However, hard computing is not capable of solving the real world problem. That is what I have stated, is that hard computing will not able to solve the real world problem to an extent. It can solve, but at the cost of time and the infrastructures. Let's see what are the difference between the hard computing and the soft computing. Before that, let me repeat the hard computing and the soft computing in a one line or a one statement. Is that hard computing deal with a precise model where accurate solutions are achieved quickly. Quickly means that has been designed, and that quickly does not mean that it is faster than soft computing, but it can able to give the precise model. Soft computing deals with the approximate model and gives the solutions to a complex problem. So automatically time will be more, and if it is a very small problem, it will be faster compared to the hard computing. So you have to keep it in your mind. The hard computing, it is for the precise model and accurate, and whereas soft computing is for the approximate model and it is for the solution. So you will see that hard computing, as I termed, it is for a accurate reasoning or accurate solutions, and it is for the precise model. So in that case, a conventional or a numerical methods, you can take it a numerical way, or the precise models you can see. You can able to predict in advance that this, based on this numerical model, this is the the particular model of the hard computing. In advance you can able to determine. Soft computing, it is for the approximate reasons, or what we have here is approximate model, and it gives a solutions. It gives a solution for the functional approximations. So functional approximations is basically the part of the soft computing case, whereas in the functional approximation we take not a numerical methods, whereas we take a values which ranges between say 0 to 1, not 0 and 1, sorry, 0 or 1. We take 0 to 1, whereas in this case 0 or 1. That is the numerical methods we take. Here it ranges from 0 to 1. So let's see the some form of a hard and soft computing. In the form of a hard computing, we give terms that hard computing is a conventional computing which requires a precise state and analytical model. So in the precise state and analytical model, what exactly it means? The precise state and analytical model is indicate that in the case of a analytical model, you have to be very sure that that particular model is having a numerical value and it is very accurate in natures. So that is it talks about accuracy, this point, and it talks about numerical values. Whereas soft computing, it talks about imprecision. So you don't need to go for a accuracy, and you don't need to go for a exact numerical. You can take imprecise values, and you can take approximate values, imprecise conditions and approximate values. Often requires a lot of computational time in the real world. So it requires more times because based on the scenario, the time to create that particular model will increase. Can solve a real-time problem in a reasonably less time. It is true that it solves the real-time. In the initial case, it will solve the problem, and from that, it will try to train itself. And as the new problem comes, again it will try to test it and try to see that if it is a new problem, then it will try to train it that particular model. So in this way, in the case of a soft computing, a improvement takes place in a fast instance, whereas in the case of a hard computing, it has to take from the ground levels. Not suitable for a real-time problem, for which ideal model is not present. Real-time world problem, it keeps on changing. So in that case, the model has to change accordingly. Whereas it is suitable for a real-time problem because the model can be flexible, and model can keep on improving. Improvement will be there in the model, and model can keep on changing depending upon the situations of the given input and or output. It requires a full truth. Full truth means that the input values and the output values should be very precisely known before designing a model. Whereas this can work with a partial truth. Partial truth means, say for example, a temperature of a room. If it has to control the fan, the temperature of the room in terms of exact numerical parameter or the full truth, no needed in the case of, just like in the hard computing how we solve. Whereas in the soft computing, we just need a linguistic variables to solve the problem. It is imprecise and accurate, and because if you want to control a fan using a hard computing, so you need a fan speed, you need a temperature of the room in terms of a decimal digit, and based on that you have to give a value to the controller, and the fan will be able to control. Whereas in this case you need a linguistic variable like a low temperature, medium temperature, high temperature, like that, and based on that linguistic variable we can take a values ranging from a 0 to 1, and then thereby we can give a command, and there we can create an inference, and inference is nothing but between the low to medium, medium to high, that particular range, or maybe a range between a low and medium or a medium and high, and thereby we can able to control. In this case the cost is high, and in this case the cost of solution is low. The same thing I have put across in this particular situation is that in the first case is that precise modeling, because it deals with the precise modeling for analysis. And the other case is that in the soft computing is that it go for a imprecise modeling for the analysis in this case. And this is for a binary calculations are used in this case, that is 0 or 1, whereas in this case fuzzy calculation is nothing but 0 to 1. So that particular situation is case. In the third case, we term that it is a 100% accurate, and whereas in this case is less accurate because we are using 0 to 1. Accurate reasoning is that means in this method we need a accuracy, that's why the accurate reasoning should be there, whereas in this case is that it does not need accurate answer, that's why approximate reasoning is needed. The computational time is more in this case, computational time is less, or we can say creating a model is time is more, in this case creating a model is less because it keep on improving. Complexity increases if the model, if the particular situations or the particular input-output condition is need to be more and more precise, then the complexity of the model will increase. Whereas in this case, complexity will become less because it works based not on the exact value, whereas on the imprecise value. It produces accurate output, whereas in this case accuracy is a less importance in this particular case. And next is that the critical system useful is that it is useful for the critical systems, whereas in this case it is useful for the decision making tools, routing, if you are having a particular controls or you are having a routine job, everything can be done with the help of the soft computing. The conventional computing is based on the analytical model. In the case of a analytical model, when I say the numerical value, whereas this is in the case of soft computing, it is a tolerant of imprecisions. It does not look for the exact numerical values. In this case, the computational time is more, and in this case is that it can solve the real-time problem with a reasonably less time, whereas in this case it requires a lot of computational times. It is not fit for the real-time scenario, or not suitable for the real-world problem, for which the ideal model cannot fit because of a static in nature, whereas this is suitable for a real-time world problem. And in this case it requires a full truth conditions, whereas it can work with partial truth. It is a precise and accurate, whereas this is it can work with the imprecise conditions, whereas high cost for a solutions in this case, and this produces a low cost for the solutions. And it is based on the analytical ideas and binary logics, and the software is used, whereas this is kept based on the minds of the users by applying a uncertainty logic or a fuzzy linguistic terms for its reasonings. So these are nothing but the hard and the soft computing as a whole that is being summarized. So let me summarize this whole particular, and that the hard computing is basically a terms related to the precise model, accurate for the accurate solutions, which is achieved very quickly, whereas soft computing is basically for the approximate model to give a solutions to a complex problem. So hard computing related to precise model, accurate solutions, and fast solutions, whereas soft computing deals with approximate model and give a solutions to a complex problem. It can be a fast, it can be a slow also, but as compared to the hard computing, it is more flexible. So let us conclude this particular segment is that the conventional computing approach in the hard computing is very effective to give a solution for a deterministic problem, because the problem in the case of a conventional systems, it increases with its size and complexity. Hence the designs in the case of a conventional approach need to increase. So this made these particular situations will not find it difficult to solve the problem of a conventional computings because of the uncertainty and the imprecise problem. So that's why the hard computing follows these conditions. If they follow this condition, then the solutions will not achieve. Hence soft computing is lot of benefit for a fast computing computationals, low cost, and eliminations of any static form of a softwares. On the other hand, if we try to look across the tolerance, the soft computing give a solutions for the complex problems, and it's having a computational intelligence. That's soft computing is suitable for the artificial intelligence to a large extent, and it works with the tolerance of even a half-truth. Hence, the approximations that the traditional methods cannot give, the soft computing methods could able to solve the real-time scenario much better way as compared to the hard computings. Thank you for listening to this particular segments. And one more point before I conclude, I would like to also add that was another basic point, is that we should know what is the applications of the soft computing and hard computing. Soft computing application is related to the wherever we are doing a recognition systems, like for example handwriting, face recognition system, soft computing is used. Whereas image processing, data compression, soft computing is used. And for a power system management, soft computing is used. Decision support systems, automobile systems, that means driverless car, soft computing is used. Whereas in the case of a hard computing, we are used for the car parking, washing machines, traffic controls. In this particular case, the hard computing is used. And however, the soft computing is hybrid with hard computing nowadays to solve even the hard computing problems also. So with this, I conclude.